Hello everybody, Mr. B here again for our fraction series. This is video 4 about the least common multiple. So what is a least common multiple, which I'll abbreviate as LCM? It's the smallest number that all the given numbers divide into evenly. And the LCM is useful for adding and subtracting fractions, which we'll see in another video. All right. So what's the LCM of 12 and 18? I'll just give you the answer here. It happens to be, if I'm on the eraser there, it happens to be 36. That's the smallest number that both, let's see, I'll write it down like this. So 36 is divisible by both 12. 12 goes into 36 3 times, and 18 goes into 36 twice. So they divide each number, 12 and 18, both divide in evenly into 36. And it's the smallest number that they both divide into evenly. Okay. Let's get one more idea going here. We can always find a common multiple by multiplying all the given numbers, but it may not be, the result may not be the smallest common multiple. The smallest common multiple is the LCM, and just multiplying them may give you it usually gives you a number that's bigger, but it is a common multiple. So like 12 and 18 multiplied at 216. And surely 216 must be divisible by 12 and 18 because we multiply these numbers to give 216. So 216 divided by 12, well, you can guess that's 18. And 216 divided by 18 is 12. But we found out earlier that 36 is the least common multiple. So 216 is a common multiple. 36 is the least common multiple. Okay, well, what we're interested in is the least common multiple. So let's work on that. There is a process that's nice to use to find it. So it involves using the prime factorization that we did in the previous video. And we make a table, and then by looking at that table, we can figure out what the LCM is. So let's find the least common multiple for 12 and 18 again. Those are the numbers we just did. We know the answer is 36, but let's see how we could do this systematically. First of all, we get the prime factorization. I've shown the tree here, the trees, to find those. And then I'm making this table. And the way I arrange the table is kind of special. We write the prime numbers in stacks. And we stack the same primes when we can. So like the 2's here and the 3's here, the same primes. And we don't mix the primes, so in the stacks. So we won't see a 3 or something in the same stack that you see a 2. I keep them separate. Okay. Now that we've got it arranged in this special way, we look at each list of the primes for the numbers we were given, which were 12 and 18. So this is one list, and this is the other one. Which list has the most 2's? Circle them. So you can see the 12 has the most 2's. It has 2 of them, whereas the 18 only has 1. How about 3's? Circle the most 3's you see in either list. So you just go through the list of primes and you circle the lists that have the most. If they're tied, like if one list has 2 2's and the other list has 2 2's, just circle one group. Not both of them, but one of them. Okay, we didn't have that happen here, but so the LCM is simply the product, the multiplication of all the numbers in the circles. So in the circles, we have 2 2's and 2 3's, and you can see that's basically 4 times 9. That's 36, just like we said before. 36 is the LCM here. So you make the table, You circle the most number of times you see each prime, and you multiply everything in the circles, and you get the LCM. Super easy, right? Okay. All right, everybody. Now we're going to move on to finding the least common multiple for 360 and 840. So I've written out all the prime factors. I haven't written the trees down, but you can get your calculator out and see if this is correct. All right, first step is look at the lists and start going through the primes. And maybe I should write a list of primes, and we can see what they are, right? We've got 2s and 3s and 5s and 7s. So who has the most 2s? We see that they're tied, right? 360 has 3 2s, 840 has 3 2s. I'm just going to circle one group of 3. Okay, how about 3s? Well, 360 wins. It's got 2 3s, and 840 only has 1 3. How about 5s? Again, they're tied. I guess I'll circle one of those 5s from 840. I could have circled the other one, but and how about 7s? 840 wins. It has a 7. 360 doesn't have any 7s. And what's the least common multiple? We just multiply what's in the circles. We got 3 2s, we got 2 3s, we have a 5 and a 7. And the number you get when you multiply all that out is 2,520. So that's the LCM for the numbers 360 and 840. So this number, 2520, should be divisible by both of these numbers. I'm just going to write these fractions down. I'm dividing 2520, the LCM, by both of the given numbers and showing that they divide in evenly. You can get your calculator out and check it. 7 and 3. So because of the process we use, this 2,520 is guaranteed to be the smallest common multiple for these numbers. Okay. It works when there's more than just 2 numbers that you want the LCM for. Like here's an example where we've got 3 numbers, and we like to know what is the smallest number that all 3 numbers divide into evenly. So again, I've written out the prime factorizations using the special stacking rules. Okay, let's go through the process. Which number has a list with the most 2s? And I think you can all see that it must be this one. For the 24, it's got 3 2s. How about the 3s? Well, 18 wins. It has 2 3s and the others have 1. All right, we're done. There are no 5s or any 7s. There's just 2s and 3s. The LCM is the product of everything in the lists. In the circles. In the circles. What do we got here? 8 times 9, that's 72. So all these numbers, 6 and 18 and 24, they all divide into 72. How many times does it go into? 6 goes into 72 12 times. 18 goes in 4. 24 goes in 3. And 72 is the smallest number that all 3 of those numbers divide into. It's the LCM for those. Okay, one last example here and we'll be done. This works when there's variables. It could be even more variables than just one. I've got one variable here, 30x cubed and 24x to the 5th. So maybe we're trying to find the least common multiple for these. These are like from a polynomial or something like that. But anyway, we still get the prime factorization, and if there's 3 x's, like x cubed, there's 3 of them, x to the 5th, there are 5 x's, you get the idea, right? Okay, how do we do this? We circle the most number of times we see each prime number. There are 3 2s in 24. That beats what 30 has. They're tied for 3s. Maybe we'll circle this 3. I don't know what's going on there. 3 and 5. There's only one 5. It's in the 30 list. Now, how about X's? Who wins here? There's 3 in the 30, and there's 5 in the 24x to the 5th. We're going to circle the 5, right? It's more than 3. Okay. So the LCM is going to be 2 times 2 times 2, 3 2s, a 3, a 5, and then the 5 x's. 5, yeah. What's the number here? Just going to write it down. It's 120 x to the 5th. That's the LCM. And you might be wondering, is that really divisible by all those, well, those 2 numbers, those 2 quantities? They aren't really, well, they're numbers if you give x a value. If we divide by 30x cubed, what do we get? 30 goes into 120 4 times, and how many x's are left? 2 on the top, and then 120 x to the 5th divided by 24 x to the 5th. Well, the x to the 5ths, those cancel, and 24 goes into 125 times. So they divide in evenly, and 120 x to the 5th is the smallest thing that both of the given quantities divide into. All right, folks, that's it. We'll see you in the next video.